Okay, so what is the maximum possible area of the triangle with these given vertices as well as these equation where the d is larger than 0? And that's the question number 8. Okay, so let's look at the problem. Like if you never tried this problem for sure, go ahead and try on your own first before you see the solution. So let's understand the question. Like we have three coordinates like a comma 0, b comma 0, and c comma d. And that is going to be triangle, and we want to maximize the area. So, and then A and B have some equation in terms of itself, and then there's also C and D is related to each other as well. So let's see what we can do. You know, we have two equations, like this expression is equal to 0, this expression is equal to 0. So the first one we have 1 plus A minus 2A squared equals 0. And the second one, 1 plus b minus 2b squared is equal to 0. If I multiply with -1, so you will get 2a squared minus a minus 1 is 0. And I think that's the same thing because they are just identical looking. I can just try factoring this guy. So that should be 2a and a. So to get -a, I need to multiply this by -1. So that should be -1. That will be +1. Is equal to 0. So the solution to this equation is -1/2 and a equals 1. And the same thing with the b. So if you do the same thing, so b is 1 or just -1/2. So let's think about what's going on the current plane as well. So what we have is like something like this. We have a current plane. We have like the a and b values, right? So the a is 1 or -1/2. So since we know that's on the x-axis, and then b is also the same thing. So which is why we can just say maybe this is like 1 comma 0. And then let's say this is -1/2 comma 0. So it doesn't really matter which point is which, because either way, this is going to be one vertex, this is going to be another vertex. And then we are lucky that because these two are horizontal, which is going to make one of the sides of the triangle. So if I name this is like A, if I call this is B, that's one side. So as long as we know the height, then we can find the area. But the question is asking us to find the maximum area, but we cannot maximize this region. This distance is just constant, right? So we want to make this D, which is going to be the like or C, because the other coordinate is like C comma D, but C doesn't really matter. It's just our x-axis, because if you choose like a coordinate point for somewhere, D value will determine our height of the triangle, either below or above the x-axis. So which is why whenever you maximize this guy, so then the area will be maximum as well. So, and also, you know, we have another equation that we never use. So let's think about this as well. This is equal to like d equals -2c squared plus c plus 1. And the goal is just to make the d is like maximum. So we want to maximize this one, but this is a quadratic equation. And the quadratic equation will be maximum like when the parabola is like at vertex point. So then we can kind of find the roots of this equation, which is exactly similar to the other one, right? So 1 or -1/2, or we can just use our like the vertex form, like negative like x over b formula, some people say. So that is just gonna be the coefficient of the linear term, which is negative of 1, so -1 divided by 2 times this, which will be -4. So that should be 1/4. So meaning that the d will be maximum at, if you choose like c as 1/4. So maybe I should make it clear. C will be 1/4 in this like equation. If you plug that, so you will get d as -2 times 1/16 plus 1/4 plus 1. So which will give us -1/8. That's 2/8. So that should be 1/8 plus 1, which is 9/8. So the largest value we can get for D is going to be 9/8. So the C is like 1/4, which is somewhere right here. So D will be 9/8. So that is gonna be C comma D. So the area of this triangle will be maximum if D is 9/8, which is achievable. So then the area would be 1/2 times the height will be 9/8 times the base, which is gonna be 3/2 units. So if you do multiply, so you will get 27. This is 8 times 4, which is 32. So that wasn't too bad, to be honest, but it wasn't really obvious kind of to see how we can use this algebraic equation with our like area of the triangle, okay, with the coordinate plane and stuff. So I hope that was clear. I'll see you in the next video.